As you can see, this session is Successes and Opportunities for ROR, the Research Organization Registry in the Asia Pacific region. Just a few housekeeping notes. You should have been notified that the meeting is indeed being recorded. The recording and slides will be shared afterward. We'll send them to all registrants and we will publish them as well. We do ask that you please follow our code of conduct. I can put a link to that in the chat. One moment. Here we are. Video is entirely optional. This is a meeting, not a webinar, but we do ask that you please keep yourself muted unless you are speaking. You can also, as I mentioned in the chat, click Show Captions in Zoom to see captions in your own language, or any language really. It doesn't have to be one that you're familiar with, but presumably one that you understand would be good. And as I mentioned, we are going to do our best to save time for questions at the end. But very often these things do run over. So we really very much encourage your asking questions in the chat during the session, and those of us who are not actively presenting will do our best to answer them. We have some wonderful speakers today. I'm going to give just a few minutes of introduction to ROR, the Research Organization Registry, at the beginning. Then we're going to hear from Aaron Ballagh, who's Director of Product at The Lens, Brietta Pike, Journals Publisher at CSIRO Publishing, Scott Edmunds, Editor-in-Chief at GigaScience Press, Masatsura Igami, Director of the Center for S&T Foresight and Indicators at NISTEP, and supported by Natsuo Onodera, Affiliated Fellow at NISTEP. With that, this is me. I am Amanda French. I am the Technical Community Manager at ROR, and I'm going to tell you a little bit about ROR right now. ROR, the Research Organization Registry, is, as you can see here, a global, community-driven registry of open persistent identifiers for research organizations that's becoming a global standard. As you may know, a persistent identifier is a digital identifier that is globally unique, machine resolvable, and persistent, meaning as permanent as humans can reasonably ensure. Importantly, a true persistent identifier also has rich associated metadata that can be retrieved using only the identifier. ROR makes information about research organizations clean, consistent, normalized, and easy to exchange among software systems so that journal articles, data sets, and other research outputs can be reliably associated with organizations such as universities, laboratories, research institutes, companies, and funders. ROR is the only research organization identifier that is free of cost, open, and community-led. So even if you haven't heard of ROR, which I hope you have, I'm sure you've heard of ORCID identifiers and digital object identifiers, or DOIs. And of course, both ORCID IDs and DOIs are also persistent identifiers. An ORCID ID identifies a researcher, a DOI identifies a research output, such as a journal article, and a ROR ID identifies an organization associated with the research, such as the organization where the researcher is employed, usually called the researcher's affiliation. Here's a sample ROR record. This record should make it clear that ROR IDs, like ORCIDs and DOIs, aren't just identifiers. The true value of these IDs is that they are associated with rich metadata about the entities they identify. So like a DOI, where you didn't know the author and you didn't know the title and you couldn't read that information about the article, wouldn't be very useful. And similarly with a ROR ID, we take a lot of pride in the metadata that's associated with that identifier. On this record, you can see the unique ROR ID at the top on the left. You can see a name for the organization, what type of organization it is, and other names it goes by. Those other names include acronyms, any alternative names for the organization, and commonly used names for the organization in various languages. Multilingual names in ROR are especially important for multilingual countries. Additional information shown on this record includes the organization's website, its location, and its mapping to other identifiers. ROR also supports parent-child relationships and sibling relationships for organizations. So you can see that here in the bottom left. This can include labs, as in this case, or hospitals or research centers, each of which with its own ROR ID. Note as well in the bottom left that you can see the record's last modified date, as well as links to the underlying metadata. You can also request a change to the record. If you want to, you can just click Suggest a Change to ask for a change to this record, and our curators will review that. We publish new versions of the entire ROR registry, usually twice a month, with new and updated records. Just a couple of facts about the entire ROR registry. It currently includes over 113,000 research organizations from around the world, with new records continually being added and existing records constantly being updated. This image is taken from the ROR browser search, but all the information shown here, plus a little bit of additional information, is also available as JSON via the ROR API and as both JSON and CSV in the free downloadable dataset. Both the ROR API and the downloadable dataset are entirely open, public domain, and free to use. As you can see as well, ROR records include language codes and support multilingual character sets. ROR records include organization names in 129 languages, including over 6,400 in Japanese, over 4,800 in Chinese, over 1,300 in Korean, and over 1,000 in Bahasa Indonesia. Of the 113,000 plus records currently in ROR, over 22,000 represent organizations in Asia, and nearly 2,000 represent organizations in Oceania. The problem that ROR was created to solve is illustrated here. Simply put, organizations go by different names, and when systems store organization names as text, it becomes difficult to associate research outputs with organizations. In particular, ROR is created to help disambiguate research affiliations, meaning the organizations where researchers are employed. And this holds true for funders as well. But in this case, this is a discovery system where we're attempting to find research articles whose authors are affiliated with a particular university. And you can see that there are two perfectly legitimate names for this university. And if you search for them, you get different results, even though these are names for the same university. So how does ROR work? One typical way that ROR is used is illustrated here. ROR is built into a system which can then share ROR IDs with other systems. It's important to note that ROR is infrastructure for infrastructure, meaning that ROR is meant to be used behind the scenes in scholarly systems. Most of the time, individual researchers should really never need to know about ROR. In that respect, ROR is quite different from ORCID and also the DOI. So on this slide, you're seeing ROR in action, even though you can't really see the ROR ID anywhere on the slide. In our demonstration system, ROR works behind the scenes to power organization lookups or type aheads. This means that a person can type any of the common variant names of an organization and choose the correct organization, no matter what they type, since both names are stored in the ROR record and associated with the ROR ID. This results in nice, clean, normalized metadata, which can then be shared with other systems and included in DOI metadata. Here's another example of how ROR works from eLife's manuscript submission system. And again, you can't see the ROR ID here, but this lookup is powered by ROR. When a researcher types the word Westlake, the ROR-powered lookup suggests several organizations, and the researcher chooses the correct one. eLife then makes sure the ROR ID is passed throughout its peer review, production, and typesetting processes until it winds up in Crossref's open metadata, which is consumed by many, many, many systems. ROR is the preferred organization identifier for several core open infrastructure services, including JALC, ORCID, Crossref, and DataCite. ROR is particularly widely used in scholarly knowledge graphs like the Lens, which we're going to hear about momentarily, and also in repository systems, and it's seeing increased adoption in publishing systems. We'd love for you to get more involved. If you want to learn more about ROR or how to adopt it, please get in touch if you're interested in using ROR. And now I'll turn things over to our first presenter, Erin Ballagh from the Lens, so that we can hear more about those who are using ROR or who are planning to use ROR. Erin?
Thanks very much, Amanda. Good morning, everyone. My name's Ballagh. I'm the Director of Product for The Lens, based in Brisbane in Australia. I'm going to talk about how we use raw data in The Lens. Firstly, for those who are not familiar with The Lens, I'm going to give a little bit of background about The Lens, which is run by a non-profit organization called Cambia here in Australia. So The Lens has three primary content sets, the first being patents. So we've got the global patent documents, we've got the world's research publications, or we call them scholarly works, and we've got the biological sequences that are disclosed in patent documents. So many of you may be familiar with The Lens as the patent lens, because it started over 30 years ago now as the patent lens and was the world's first free and open full text patent search facility. We then started ingesting and providing a search facility for the biological sequences that were disclosed in those patents. And that became one of the world's first open resources for patent sequence searches. And then in 2011, with seed funding from the USPTO, we started extracting the non-patent literature citation strings out of the patent documents and matching those to research publications in PubMed and Crossref. And that led to the development of the scholarly works indexed in The Lens in 2017, when we added the Microsoft academic data corpus, and we since have increased that to host the majority of the world's research publications. So The Lens is now one of the world's largest innovation knowledge platforms. It's free and open. We use fair data, and that's why we use raw data. It's community sourced, so we can provide our open data to everyone. And the platform has been up for over 24 years now. So just looking at those content sets and starting with the scholarly works, we have over 284 million scholarly works records, or meta records as we call them. And we create these meta records by combining data from multiple data sources where we get data for the same publication in this case. So our primary data sets are Crossref, PubMed, OpenELEX, and Microsoft Academic. And we combine that data and supplement it with additional data from supplementary data sources such as Unpaywall, Open Citations, DOAJ, ORCID, and of course, ROR. And that gives us our 284 million meta records. There are over 5.6 million of these scholarly works have been cited in patents, so we were able to match one of the patent citations to a scholarly work. And there are a total of 97 million scholarly citations for these scholarly works, giving a total of 2.3 billion scholarly citations across the data set. We've also got over 10 million full text scholarly works indexed for discovery. In terms of the patent data, we've got over 161 million patent records, and this comes primarily from three main data sources, those being the US Patent and Trade Organization, USPTO, the European Patent Office, the EPO, and the World Intellectual Property Office, WIPO. So that gives us our patent records covering 106 jurisdictions and representing 90 million simple patent families, which is effectively a single invention. And we have nearly 1 million patent documents that have biological sequences disclosed for a total of over 500 million biological sequences. And that gives rise to our PatSeq facility. So we index those biological sequences in a tool we call PatSeq Finder. It's a basic local alignment search tool that provides a search functionality for sequences. So the use cases for these are where pharma companies will be looking for similar sequences in the patent literature to what they're working on, either for freedom to operate or infringement searches. So those are the three main content sets, and that allows us to do what we think we do uniquely, is create an open knowledge graph by linking these content sets together, so that we are able to link the patents to the scholarly works through those non-patent literature citations I mentioned. Excuse me. And the patents are linked to the sequences, and this gives us over 2.5 billion document linkages across our data set. Which allows us to provide tools such as the International Industry and Innovation Influence Mapping tools, or we call them INFORM. So although the Lens focus is primarily on accelerating innovation, Many users actually use it for research assessment and research performance because it's an open and verifiable tool and provides an alternative to the public to closed proprietary platforms. Thus our approach to open data. So it also allows individuals or institutions or even countries to identify the research output and identify the impact on, let's say, industry through those patent citations. You can also map the influence on academia through the scholarly citations. And this gives us an alternative to the traditional research assessment tools and is our informed research mapping tool. We also use it to provide a metric for institution. Some other tools the Lens provides that may be of interest to this group is the Lens Labs, which has community open apps and data. So we collaborate with members of the community on the open data that we provide to create additional tools such as network visualizations or systematic review tools. So that may be of interest to those of you who are not familiar with the Lens. And we also provide institutional toolkits to institutions, including universities, for a number of different use cases across libraries, technology transfer, the research office, etc. One of the primary tools here is the API access, which provides our metadata, including some raw metadata, which we'll look at. And that's useful for updating institutional repositories, for example. So the raw data that the Lens integrates into the Lens platform is used to help standardize our institution names, as Amanda pointed out. And we add the location and additional information on the institutions into our database, and we index that for discovery, and it allows us to create fields that help us drive the platform. So for filtering and for analysis, we also provide that metadata in the API and export. So what that looks like, we're getting data we're ingesting the full raw data set and combining that or merging it with data from OpenAlex and Crossref, which include raw identifiers. So we merge that data and we were then able to add the additional metadata from the raw bulk data, which includes the location information and the institution type. We're also doing some matching and overrides of ourselves. So where we don't have a match or where we don't have a raw identifier for an institution associated with affiliation, if we're able to get a match against that institution name, we add the raw identifier. And then we merged that data and indexed it to basically drive a bunch of the functionality on our platform, including the analysis, the charts, the dashboards, the reports that use raw related fields. And we include that metadata in the API and exports for others to use. And just quickly, a timeline on the integration of RAW. So back in February 2022, we first migrated from the grid data to RAW and started ingesting the raw metadata. We were subsequently able to add fields, metadata fields for filtering, for example, and updated our metadata schema, the raw schema, I should say. And then late 2022, we implemented what we call the raw lineage field. So because those raw has the relationships between the parent-child institutions, as Amanda pointed out, we've able to index that relationship because we had the full data and provide a field that allows users to search for a parent institution based on their raw identifier, but also pick up any scholarly works that are associated with children that may not have the parent identifier. So it allows you to capture everything that's included in your institution as well as the child institution. We also added matching against the author affiliations for over 500 institutions. That's over 1,000 now. And we have since, or just recently rather, increased the coverage of the location information that we get from RAW by supplementing it with data from geonames. And if I have time, Amanda, I'd love to show quickly that on the platform. That was the end of my slides.
Yep,
so let me
got time.
my screen.
Not long, but you can have a minute.
That should be enough. Okay. Yeah, see my screen? So I'm just going to jump into our scholarly work search.
I don't think we can see your screen, or maybe. I don't know.
That again.
There you go.
Excellent. So I just jumped into our scholarly work search. So the filters that are supported by ROR, so the institution name is the primary one. We've also got the institution country and region. So I can use that to filter for scholarly works that have authors affiliated with institutions in, we can look at Japan and Australia, for example. We can see it's helping to drive our institution name logo, show the use of the ROR identifiers within the author affiliation. So this one is matched to Curtin University in Australia. You can see the ROR identifier there. I can filter by institution. So I can now filter on the University of Tokyo, for example. We can see we've got 469,075 works. And if we have a look at that ROR record, we can see the University of Tokyo has 4 related or child institutions, I should say, child organizations. So we can actually grab that ROR ID and use it in the ROR ID lineage field. Institutions, ROR ID lineage. I've pasted in that ROR identifier for the University of Tokyo. Let me clear my filters. So you can see now we're getting an extra 300 scholarly works compared to what we had previously. So there are, we're now picking up an additional 300 from one of those 4 child organizations for the University of Tokyo. That's mainly what I wanted to show. Also, the fields that we use from the ROR metadata to drive our analysis. So obviously the field name, we use the logo grids and whatnot. We use the country information for the institution to create maps. So we can get top institutions by, top countries there in a bar chart, or we can visualize that in a map. We can see, obviously, we're looking at the University of Tokyo, but we can also visualize other fields such as the cities, the state, and the institution type. So that's primarily how we are using raw data in the land.
Very exciting. I think that was 2 minutes, but I love that so much. That feature, that's very cool. I shared a link in the chat to a post that we did that featured some of that. Thank you so much, Aaron. We're going to hear now from Brietta Pike, who's journals publisher at CSIRO Publishing. And Brietta is going to talk to you about not using ROR in a way, about planning to use ROR. Obviously, the ROR integration in the lens is very mature, very advanced. You've been adding multiple features with ROR, but we really wanted to get a perspective from somebody who is interested in using ROR and is thinking about how to do that. Brietta?
Thanks so much, Amanda. And I think, already what I've heard today, that we're at that early stages of looking to incorporate ROR for our author affiliations and our journal publications. And there's a lot of learning. So thank you. So I can skip the introduction since you've done that. Just hello from Melbourne, Australia, everyone. So who's CSIRO Publishing? Just for a bit of background. CSIRO Publishing is Australia's leading science publisher. We're owned by a research organisation, the Commonwealth Scientific and Industrial Research Organisation, or CSIRO, which is Australia's national science agency. So we're in the public sector, not privately owned. But as part of CSIRO, we're part of the scientific community. We're editorially independent. We're a commercial operation, but we're a not-for-profit publisher. And we're not funded by CSIRO. So in terms of what we publish a wide range of books, from children's books to to field guides, professional and academic books. We also publish journals, magazines, and we offer writer training to researchers. We are a small team, all located in Australia. We're approximately 45 people, and we're supported by 75 years of scholarly publishing experience. So to talk a little bit more about our journals program, because that's what I'll be focusing on today, we currently have 30 journals in our suite. We own 15 of these journals, and the oldest we've been publishing since 1948. 11 of those 15 have been publishing for more than 50 years, many of them much more. The other 15 journals are owned by societies or other partners, and this includes 2 new journals that we're happy to be starting to publish from 2025, Public Health Research and Practice, and the Australian and New Zealand Continents Journal that we're welcoming to our suite. We publish research, not just from Australian researchers, but from international researchers across a range of scientific subjects in our journals: health, natural environment, agriculture, chemistry, plants, animals, other things. All of our journals are peer-reviewed, members of the Committee on Publication Ethics, and have external editorial boards composed of active researchers managing the peer review process. As a small publisher, we pride ourselves on a supportive and accessible service for our authors throughout the process, and our editorial assistants and production editors are based in-house for most of our journals. Our policies support the importance of high standards of ethical behaviour throughout the publication process and demonstrate our commitment to openness, transparency, and reproducibility in publishing. So to turn to metadata, I have to say we're not where we want to be with the metadata for our journal articles. Although we've been producing full text XML since 2004, and we've updated DTDs over the years so that our most recent output is JATS 1.1, we've not prioritised enough as a business resourcing to ensure best practice tagging within our XML or completeness of data. We do now have a project team that's been put in place for a couple of years and provided some time amongst other priorities to focus on improving metadata, and this is something we're really passionate about. Initially, time was spent on learning and understanding where we were and what we needed to achieve. And I think a big challenge is realising that implementing changes to ensure robust and quality metadata in a lot of cases involves multiple teams, workflows, system changes across the business, and these aren't small changes. So one of our key challenges is still resourcing to keep up, also with the changes that are constantly happening. A big challenge we had until last year was that we didn't have an XML style sheet or a dedicated document dictating the tagging in our XML, which meant that we have 2 production suppliers who were providing us with slightly different tagging in the XML. So we mapped an XML style sheet to ensure consistency, and during that process, we worked with our suppliers to improve the tagging of certain elements in our XML to best practice and implemented these changes in our workflows, which was a big step. We've also been working on improving the quality of our data, so whether that's the quality of the author supplied data, or we were losing a lot of data during production and working on rectifying that, or on sending more complete metadata to downstream partners. Collaboration with partners has brought us a long way and will bring us a lot further. So I'll share our Crossref participation report on the next slide, and feedback from Crossref has been really important for us in prioritising and making changes. We've also had more conversations with other indexing aggregation partners about the data we're passing to them. But yeah, with the industry moving so quickly, staying up to date is vital, and we really appreciate the opportunity to be part of opportunities like this, where we do get to talk to colleagues within the region and not in the middle of the night. So thank you for that. We're in the process of migrating our content from our self-hosted platform to the Silverchair platform, and our content and our metadata will be improved as part of this process too. So again, from that collaboration, the advice provided by Silverchair, and as well as some additional resourcing on improving our content for this migration will improve our metadata. I do want to mention that the preparation of content for this migration is being done entirely in-house. And as part of that preparation to provide Silverchair JATS, we're also upgrading all of our XMLs in our archive to JATS 1.3 and preparing an XML metadata header for all of our old PDF only content, which has previously been displayed on our site by information hosted from our content system. So we're in the thick of this work at the moment and enriching metadata fields for the archive when we can as well. And moving to a big platform, a Silverchair platform, will also provide us with additional benefits, of course, so the discoverability and ensuring that we can more easily stay up to date with technologies and developments, which are challenges we particularly face as a small publisher. So all of these efforts are leading to richer, more complete metadata and better discoverability. So I mentioned the Crossref participation report for us, our member report, and how this has been instrumental for us in providing targets and aspects we can improve on, as well as how we're tracking. And this is our report as of yesterday. So there are lots of holes. There are some things we've been doing well for a long time. So we've been depositing references, abstracts, and ORCID IDs, similarity check URLs for many years. As part of our more recent work, we've started depositing funder registry IDs and funding award numbers. And that work was one example of where we needed to make improvements across our workflows. So in the submission portal, to facilitate authors to provide better metadata during our production processes, to ensure that metadata was verified and as accurate as possible. And then also in improving the funding tagging in our XML to capture the funder name, funder ID, and grant number. And this improvement in our metadata provides a transparency on who funded the research and is really important for the research ecosystem. And we also similarly worked on the license URLs, which we will start depositing to Crossref soon too, which brings us to the affiliations and ROR IDs, which are the next items for us to tackle. So this is new. We haven't started planning in detail yet how we're going to go about the author affiliations and ROR IDs. It's something we do want to implement by the end of 2025, so it's very timely for us to start this discussion. So some of our challenges, I guess a key one is that the different institutional PIDs that are around in the ecosystem. So we're actually collecting Ringgold IDs in our submission system, Scholar One, and we also use Ringgold IDs to automatically match authors to open access agreements they would be eligible for using RightsLink. We're not including Ringgold IDs that we're collecting in our XML outputs yet. And I think that's largely around that we're first wanting to review our affiliation data and have questions around best matching there as well. So we want to be confident of that, maybe review our workflows and policies before we start to include any PIDs with the affiliation data. So I guess the sort of challenges that we've got at the moment are, for example, instances where authors may include slightly different affiliation data on their manuscript versus what they put in Scholar One, like including a department name in one place or not the other. And we first need to have a process in place to ensure that those two places match, the Scholar One and the manuscript, completely. We also question if the way the author lists their affiliation is the way the institution wants it to appear, and what's our workflow for going back to authors or so forth. Can we change what the author supplied on the paper to match how the institution's labelled in a database? What's the source of truth? So seeing your presentation, Amanda, I'm sure you could help with a lot of our open questions. And then just up here as the final challenge is the transformation from Ringgold to ROR, to include the ROR in our XML. So we've done some testing on this, and it doesn't really seem to be a major challenge, but it's just noted as something that we need to also build into the process. So what are our next steps? So we plan to firstly do a case study or a review of author affiliation data. So looking at a sample of published content, comparing the affiliation for all authors in Scholar One versus on the manuscript. Are there discrepancies? What do we see? Reviewing our workflows, asking questions like, do we need to improve our data collection? Should we be checking each author's affiliation directly with them instead of relying on the corresponding author for verifying all authors like we're doing at the moment? Should we be matching to parent PIDs or going more granular? What are our rules for matching? And then when we're more confident in our data, we'll ask our suppliers to start to include Ringgold IDs in the final XML. And then following, we can work on transforming to RORs and depositing affiliations and RORs with Crossref and other downstream partners. Down the bottom, I've just got on the radar for the future to switch to ROR from FundRef, and we don't have any sort of time frame around that. It's just more on the list for the future. So thank you for this opportunity. I'd like to thank my colleagues, in particular Emma Proudlock and Joseph Chan, for all the work they're doing on this project. We feel really strongly about our journey to better metadata and to building trust in the outputs we publish, providing structured knowledge that will facilitate interoperability, transparency, communication, and we'll be really keen to talk to anybody about metadata experiences. So please do get in touch. Thanks.
Thank you so much, Brietta. That's great to hear, and we are here at ROR to help. So we'll be in touch. I'd like to hand things over now to Scott Edmunds of GigaScience Press. Scott?
Hello, hi. Swadika from Thailand, where I'm at a workshop at the moment. So I'm also providing a case study from a publisher perspective, although not at the beginning stage. We're sort of somewhere in the middle, but not quite at the end. And this is going to be a case study on looking at slightly different things, really focusing on the machine readability part and what ROR has the potential to add here. And this is from the perspective of a publisher focused on open science. So we publish data, we publish software. As an introduction, I'm the editor-in-chief at GigaScience Press. We are published by BGI Hong Kong, which is part of the BGI, which has for-profit parts and not-for-profit parts. And we're an open science publisher of currently a couple of journals, Gigabyte, GigaScience, which is also co-published by Oxford University Press. And we have a data publishing platform, GigaDB, that helps our sort of data publishing activities. And you can kind of see that ROR can kind of fit into these slightly different use cases. And as I say, we're based in Hong Kong, based in the Asia Pacific, and I'm talking about machine readability here. So this introduction can be kind of expressed with persistent identifiers. On the right here, I haven't put the contextual kind of relationship metadata in here, but this is how kind of machines would sort of understand more accurately, be able to properly disambiguate all of these different things I'm talking about. Now, very grateful being based in Asia Pacific, very grateful that, ROR are thinking about our time zone, thinking about our part of the world. People in Asia Pacific, I'm sort of preaching to the converted here, but, we know that we're not an afterthought for these things. We are probably the most scientifically productive region in the world. You know, just looking at the Asia part of Asia Pacific, we're 60% of the land mass, 60% of the population, and looking wider at the scientific outputs. Now, you know, in terms of, you know, scientific publications, China is you know, the biggest producer of these. India is kind of rapidly catching up and is third. We have huge players like Japan, Korea, Australia. In terms of research funding, you know, there's different levels of countries, amounts of funding, but, you know, we have places like Singapore with, you know, probably the highest, you know, per capita GDP research spending, R&D spending. So we have, you know, huge amounts of people working here, leading the world in many areas like AI, just look at DeepSeek and things like this. So we should be overrepresented in many of these things, but when you know, look at many things, we're unfortunately underrepresented. Looking at ROR, you know, when there's over 100,000 organizations here, currently China comes up, you know, slightly less than 5,000. And you can say the same thing, you know, there's underrepresentation in orchids, in many of these different things. And research is kind of complicated here. You know, language as different languages has made these things challenging. And the way that research is handled in many countries, for example, China, these parent-child organizational relationships are super complicated. The way research is funded at the national, regional, even down to like city and city district levels is complicated. And so systems, just looking at this from a, you know, identifier perspective, it's been challenging to kind of populate and accurately kind of capture this data. My own organization, the data has been completely wrong. In Wikidata, even the Wikipedia page uses a name that's 20 years out of date, has no understanding of the parent child, which is the main organization, which are kind of subservient to that. And so my own metadata is still currently incorrect, saying I'm part of an organization that I'm not. ROR was incorrect as well, but the function that's really fantastic for this kind of use case is ROR is super efficient at letting you fix your own data to the level of even issuing pull requests on GitHub. So I fixed it, and, you know, I fixed all of my organizational data in ROR. I fixed it in Wikidata as well, and it hasn't quite like fully caught, you know, the other sort of downstream platforms hasn't fully caught up with this. It's still in some places saying it's wrong, but this is a really nice feature from that ROR provides that we particularly have found. So going back to our journals, we have a new journal called Gigabyte that's really focused on machine readability and leveraging a unique XML first platform that's been developed by River Valley Technologies that doing everything in XML, we've really kind of pushed that to the limit in how we can use this technology to publish our open papers, publishing open data and the like. So because it's almost completely automated, we can do things like do multilingual publishing at very little extra effort, add interactive features. Going back to the XML, you can switch different views of the papers. And that's from, you know, increasing accessibility for humans, but we've also gone to a lot of effort to increase accessibility for machines, thinking that the machines are more and more our future kind of reader base for these things. We've done experiments with frictionless data palette packages of the data that we publish, and to the level of even putting nano publications in some of our papers as an experiment, and persistent identifiers have been key to this, to really allow the machines to really figure out what the entities are in the paper and, you know, properly disambiguate them. Obviously, the authors relate, you know, and all of the relationships there. ROR is key for, you know, the funder and institutional perspective. We go to the entities that are discussed, like species identifiers, cell and strains, and equipment and software. We use a number of persistent identifiers for these. all the way to the outputs, like the data outputs with data DOIs, results, and as I mentioned, like assertions, which at these sort of nano publication level, and really thinking about the interoperability and getting papers kind of, getting research AI ready. So, we've been going to these efforts, adding all of this information in, and so what are the consequences of this, right? And we have a data mining portal as well that makes it super easy to like download all of our content completely openly. And so, yeah, the downstream consequences, the big one is obviously AI, LLMs. It's been super interesting to see, open access was the licenses and Budapest and all of these things were, 20, 25 years ago. And they were very clear that machine readability was going to be a key part of this. We didn't really know the implications of this at the time, but the implications now are that court case to find out what the training sources of ChatGPT, the number one publisher, the number one source of accurate peer-reviewed information training these LLMs is the PLOS corpus. Number 2 has been Frontiers. Number 3 has been the open access Springer corpus. Whether they're getting a free ride or what is a debate for another time. But it's super important to just make the internet work, to encourage open source AI. And the other sort of immediate thing as well, our particular use case has been, we've been first working with the OA switchboard. It's kind of a Swift code for research, and so allowing institutions and funders to track where open access content is being published that they fund. And so currently we've just started adding RORs into the XML. So OA Switchboard uses ROR to provide, through their APIs and these kinds of communication, but we're actually making our the papers themselves actionable. Basically machines can actually figure out from our XML and share this kind of information. So this is where we're sort of at the moment. We're still in the process of fully integrating this in the database, for example, which is currently just adding things in manually. We're completing this process for the journals that we have. We're completing OA Switchboard integration. We've just done some testing last night, actually, that I need to check. And these sorts of case studies are for, actioning persistent identifiers will be ongoing. And wearing my hat as an advisor of Make Data Count, it's important to actually track this, collect this information, use this to assess what is actually coming from this, right? We need use cases, and we also need quantitative data to help show the benefits of using persistent identifiers like ROR, increase the uptake in Asia, move, and assist people moving from these sort of proprietary, expensive brand indexes to open community infrastructure, which, hopefully this very quick talk will shows some of the potential. So yeah, thank you.
Thank you so much, Scott. A lot to think about there. I find that ChatGPT slide very, very fascinating in particular. Okay, we'd now like to turn presentation over to both of our presenters from NISTEP, Masatsura Igami and Natsuo Onodera.
So, hello everyone. My name is Masatsura Igami, and I'm from the National Institute of Science and Technology Policy, Japan. So it's a great pleasure to be here today to present our motivation to link the NISTEP Organization Dictionary with ROR. So to begin with, I would like to explain why we see value in linking our dictionary with ROR. Our dictionary is currently used almost exclusively with Japan by linking within the Japan. So by linking it with ROR, we aim to extend its reach to a broader international audience. At the same time, we recognize that potential of ROR as an international registry of research institutions. While ROR is widely known in global research community, so its recognition in Japan remains limited. So it's my opinion. But so by linking ROR ID with our dictionary, we hope to introduce ROR to more users in Japan, thereby contributing to dissemination and adoption in Japan. So before discussing our dictionary in more detail, let me briefly introduce NISTEP. So our institution is a government research institute affiliated with the Ministry of Education, Culture, Sports, Science, and Technology. So NISTEP was established to support national science technology policy making by providing data-driven evidence and analyses. So our research, and this is our organization structure of NISTEP. So our research covers a wide range of topics, including science and technology indicators, various analysis of scientific papers, and benchmarking studies of scientific research and universities. So another important aspect of our work is the development of data and information infrastructures, such as NISTEP Organization Name Dictionary. So this dictionary is the basis of our analysis. So now let me explain the role and characteristics of our dictionary. The dictionary plays a central role in NISTEP's effort to compile and publish fundamental data on research activity of Japanese university and public research institutions. So it is designed primarily for research managers and administrators who wish to compare their university research activity with others, as well as for researchers who need systematic data to analyze national R&D or innovation system. So one of the key features of our dictionary is its comprehensive coverage. So it systematically corrects and maintains basic information of major research institutions in Japan, including the university, public research institutions, local government agencies, and private companies, and non-profit organizations. So additionally, it includes a major subsidiary organization focusing on the 44 universities, 4 inter-university research institutions, and key national research institutions in Japan. Unlike other datasets, our dictionary also attempts to include non-existing institutions, linking them to their successor organization to provide a continuity in historical analysis. So the dictionary has been updated and published annually since 2012, and to support international users, an English version has been made available since 2020. So this is this slide shows the structure of our dictionary, but I will skip this one. And this table shows the coverage. As for the primary organization, the dictionary contains about 50,000 organizations. As for the subsidiary organization, it includes about 5,000 organizations. So while we believe that linking our dictionary with our ROR will bring significant benefit, but we also recognize certain challenges that need to be addressed to facilitate ROR's adoption in Japan. So one major challenge is the visibility of ROR in government agencies. If ROR ID can be effectively used to visualize the flow of research funding, outputs, and outcomes in the national innovation system, then policymaker become ROR may become more attractive to policymakers and funding bodies. So however, in Japan, access to the data, particularly input data, such as research funding and resource allocation remains restricted in many cases. So the openness of data is one issue to the use ROR in the analysis. And another important factor is the need to align ROR with the international classification standards. So many users are not familiar with the research system outside their own country. So therefore, incorporating the widely recognized sector classification, such as those defined in the OECD Frascati manual, could add significant value to ROR and make international comparison easier. So this is the final slide. So based on the past validation studies, we have identified the two key aspects that should be considered when using ROR. First, from the perspective of the research institution repository, ROR includes entities that are not necessarily recognized as a research institution. So second, the coverage of Japanese research institution is ROR is not yet sufficiently high. Therefore, users need to be aware of potential differences in coverage across the country when utilizing the ROR data. But we analyzed in recent version and we find that the ROR shows a significant improvement. So I would like to congratulate the ROR team about the increasing of the coverage. So another notable feature of ROR is its metadata, especially the link field. This feature is not currently included in our dictionary, but we recognize its usefulness and would like to introduce it to the Japanese users. Like, I mean that this links means a link to the URL or homepage of the research institution. So in conclusion, the ROR efforts targeting research institutions around the world are variable. So believe that the ROR itself can be further enriched by the connecting the effort being made in each country as a networks. We are very happy to contribute to these efforts. Also, thank you very much for your attention.
Thank you very much. That was fascinating, and thank you for the compliment about the improvement of Japanese records. I may say that we have our curators on the call, Adam Buttrick and Riley Marsh, and we had just said yesterday in our community update that further improving coverage of Japanese organizations in particular is a focus for 2025.
Oh, that's great.
So we have 1 minute for questions, which is not so bad. We are perfectly willing to stay around as long as necessary. At least I am. So I would love to hear anything that anyone would like to ask or comment about. I noticed someone in the chat mentioned visited our open queue of requests for changes to ROR. Scott also very, very kindly mentioned how easy it is to request those changes and that eventually those do filter downstream. And I did want to mention that we've seen that number of requests go up and up. We're very, very committed to processing those quickly and making sure that they're accurate. We do have centralized curators who review those requests. It's not always automatic, but we do have processes to make that process quite quick.
I would add to that, Amanda, that we do direct users to ROR, where we have a lot of requests for the data to be broken down to lower level child organizations, I guess, within an institution when the institution is doing research performance assessment. So we do direct users to the ROR support section there to update their institutional, their child institutions, because you're right, that does feed through, and it, with that ROR lineage field, that it does allow that, that parent aggregation as well as the individual child institution.
Yeah. We do have a question in the chat that I think probably is best addressed by Adam, our curator. Can you update us on the migration of the funder registry into ROR? Adam, would you like to address that?
Yeah, so the funder registry reconciliation into ROR is essentially been an ongoing and continuous process for the past 2 years. We've achieved a very high threshold of overall reconciliation between funder IDs in approximately the 90% range of funder IDs that have data assertions. Once we get into that last kind of 10% threshold of things that are actually being asserted on works, it requires a lot more careful curation attention, specifically because the number of assertions tends to go down. So we work through those in the same way that we process all of our other curation requests, kind of one at a time with a lot of manual review. Also, a lot of the kind of blockers to getting those added is because they require a lot of regional expertise. So for example, we currently have some contract staff right now helping us with Chinese funding organizations and parse those out, because I think, as Scott mentioned, in some of the existing funder registry reconciliation data, how those funding programs were actually represented doesn't correspond to the actual representation in China of funding organizations. So we want to make sure that we're not just inheriting bad or incorrect descriptions, but we're kind of looking at them from first principles, from the perspective of how the Chinese research landscape is actually organized and correctly capturing. I think we had Jackson, the person who's doing that work, speak at one of our calls back last year sometime. I don't remember the exact session, but they went some very detailed analysis of Chinese funding organizations. Yeah, so we'll continue to do that work through most of this year. It's another one of our priorities that Amanda mentioned relative to curation activities. Yeah, I don't know if there's any other questions that came in relative to funders. There was a question about funders versus funding programs. Yeah, this is an interesting one, which gets down to the specificities of how things are handled at the level of, you know, kind of country level funding mechanisms. So, for a subset of countries, there have been included records for funding programs that are often term limited or are kind of parallel representations of funding organizations through various instruments through which they funded work. So when we tackle those records, what we try and do is identify to what extent they map directly to a funding organization and can be included on that basis. So ROR allows for a one-to-many relationship between external identifiers such as funder IDs. So what we do is generally link those to the top level funding organization. If we have to do anything that's more complicated, we try and document it to the best of our ability. So as I said, relative to that project for Chinese funding organizations, in addition to doing this sort of mapping of funding programs to Chinese funders, we're actually trying to do a more kind of detailed analysis of the overall kind of Chinese funding landscape, such that we can provide a clear picture of what is happening. Instead of just inheriting and kind of reifying translated forms of names or more informal kind of funding structures.
Yes, thank you, Adam. Unfortunately, Brietta had to leave before I could thank her. I want to address at least one more question, but before anyone else has to leave, I do want to give tremendous thanks to our speakers. We very much appreciate your taking the time to present to us. It's very, very much appreciated. We do have a rather interesting question, at least to me, in the chat. A repository administrator working with metadata asks, some of the ROR identifiers can be retrieved from ORCID, but we might have to enter ROR IDs manually. And I think that is actually a very fascinating question. Our efforts have been primarily toward building ROR into systems. I showed a couple of examples of where ROR is built into software so that when a user types, they enter a ROR ID without even knowing it, essentially. However, it is certainly possible, and many people do add ROR IDs manually to XML. And I think I know of several examples of people who do this, but we don't actually, I think, have a lot of great documentation and examples about that. It is entirely possible to build ROR, to add ROR into Dublin Core. I have actually had on my to-do list for a while to add that page about how to do that. And so I am going to get back in touch with you, Kosuke. I'm going to put that page up and let you know how to do it. Adding ROR manually is not ideal, but there are actually a number of repositories that I know that are doing that. They produce XML, they update the XML essentially by hand. Maybe it's copy paste. But especially for institutional repositories, it's quite simple because it's usually one ROR ID, like, or at least for a lot of them, this researcher is associated with this institution. So Kosuke, I will get back to you for sure. Making a note of that. Well, thank you very much. I will send out the recording and slides within a day or two. Thank you all for joining, and I hope you have a wonderful day.
Thanks so much, everyone.
Bye.
Thank you. Bye.